Well, in this session we will be looking at arrays, their creation, operations and manipulations. Let's begin quickly. I define a matrix A by writing A is equals to 1, 2 and 3. We now have a matrix called A. Let me clear the screen and begin from the first so that you don't get confused with what I already written there. So A is equals to 1, 2, 3. When I type and press F9, it basically evaluates a particular selection. I find out the matrix that I have defined is A is equals to 1, 2 and 3. Okay, that is one thing. And how do I create a multi-dimensional matrix? Let me first create a two-dimensional matrix. I'm going to create first the first row and the second row later, 0, 9, 7, 6. Right, this is the second row. Notice that when I wanted to go to the second row, I actually use a semicolon symbol. Right, when I select this and I press F9, I get that the two-dimensional matrix that I wanted is P is equals to 1, 2, 3, 4 and 0, 9, 8, 6. Right, notice that if I put a semicolon at the end, it does evaluate but it does not display the result. Right, that is one thing. Now what if I want to find out the number of size, number of rows and number of columns in this particular matrix? Right, basically I want to find out the size of this particular matrix, which I know that it is 2 cross 4. Let me find out by using MATLAB. Size of B, and when I write and I press 9, I get 2 cross 4. Right, it has 2 rows and 4 columns. It is pretty obvious. And if I want to find out the number of rows specifically, then I would give size of B cross B comma 1 and F9. Right, that is one thing. And I can also define size of B cross 2 as the number of columns. Why do I use 1? Alright, 1 means the first dimension, 2 means the second dimension. First dimension is always for the rows and second dimension is always for the columns. Okay, that is finished. What if I want to find out the total number of elements in this particular matrix? I know that the number of elements in this matrix is 1, 2, 3, 4, 5, 6, 7, 8, total 8. Okay, basically I should be able to obtain it by multiplying the size of the number of rows and the number of columns. And if I execute this, I get number of 8, which is absolutely right. But there is a simpler way of doing it. Numeral of B. Okay, that means basically number of elements in B. Right, at F9 I get value of 8. Right, which is pretty simple. Right. So now that is finished, and basically now we proceed on to further more interesting operations. And now let's now create a particular matrix. There are other ways of creating a particular matrix. Right, now I want to define a matrix of A. Okay, this particular matrix has to start with I and end with a final value of F, and it should have an increment every time. So it's like the matrix should start with if initial value is 0 and increment is 2, then the matrix is going to have values like 0, 2, 4, 6, etc. up to F. Right, now let me define value of I, value of 2 and value of 10. So what do I need? I need to create a matrix, okay, starting from 0, or an array starting from 0 and ending till and going up to 2, up to 10, sorry, in steps of 2. So how do I do it? Right, so the matrix that I need, A, it's starting from I, having an increment of INCR up to F. Right, I press F9. Oh my god, INCR is not defined. Why? Because I have not executed this before. F9. So now I execute this. I actually get the values for A, 1, 0, 2, 4, 6, 8 and 10. Right, so now this is one way of creating a particular matrix by using colon operator. Right, notice that the distribution of the numbers between 0 and 10 is uniform. Right, so now you can also create a matrix when you know the initial number and you know the final number, but in this phase you don't know the increment values, but you know how many numbers you need between I and F, with I and F included. Right, if that is say around 4. And how do I create? A will be, I want a linear spacing. Okay, linear space between I and F. How many values do I need? I need n number of values. So I need, oh my god, once again the same mistake I'm doing. Okay, once again evaluate everything. Now I get 4 distinct values between 0 and 10. In between there are 1 and 2. Right, so there are how many values do we have here? There are 4 values between 0 and 10 with 0 and 4 included. So 0, 3.3.3, 6.6.67, 3.3333, 6.6667, and 10.0000. Again, this is finished. Linspace command is finished, and so we basically learned 3 different ways of creating an array. One is manually creating by using square brackets, and the other one is by using the colon operator, and the other one is by using the linspace command. And you also learned about the size command and the numeral command, right? Pretty much handy, right? So now I want to create a random matrix, all right? Rand of 3, 3. Let's see what kind of a random matrix it produces. Basically, it produces a random matrix of the size that I specify, in which case the size I'm specifying is 3 cross 3, and every element in this particular matrix is between 0 and 1, right? So now this is a particular matrix. So this is, if I run this once again, it gives me a whole new, every time I run it gives me a new matrix because it's a random matrix, right? If I want a random matrix between 1 and 2, or between say 2 or between 3 and 4, right? I will just add 3, 4, big deal. All right, F9, I get this much, right? Pretty much. And what if I want the values of the random numbers between 0 and 3? I would multiply it. In this case, I'll be getting 0 and 3. That is one thing. Okay, we have learned a lot about RAND command. You can learn more by exploring further. And you also have a command called ones command, ones of 2, 4. Basically, when I press this, it's going to give me when I press it, when I execute it, it basically gives me a matrix having all elements as unity, right? Similarly, I also have a zeros matrix, zeros of 4 cross 4. F9, when I do this, I basically get 0, 0, 0, 16 zeros ordered in terms of 4 rows and 4 columns, as just as the way I specified 4 cross 4, right? That is one thing. And now what about an identity matrix? EYE identity matrix of say around 5 cross 5 matrix. When it executes, you see the principal diagonal values are all filled up by unity, right? But it just works fine for non-square matrices as well. 3 cross 4 is going to give you the first principal diagonal element, or the principal diagonal element will be filled to the extent possible. 1, 1 and 1. The remaining will be kept as zeros, right? So now this will also work pretty much the same in terms of 6. I have F9, so it fills up like this, and 6 cross 1 will fill it up like this, and 1 cross 6 is going to fill it up like this. Principal diagonal elements will be 1, right? Now let's say that A is equals to RAND of 3, 3, and basically shift home. Yes, F9, I get this particular matrix. And what happens if I write A dash? A dash means it's basically the transpose operation. Now you can see the rows and columns have been interchanged. This remains the elements along the principal diagonal remains the same, but other things will get interchanged. All right, this comes here, this comes there, this goes there, this goes there, this one here, and this one here, right? It's basically a transpose operation. Okay, so now what about can we also find out the determinant of this particular matrix? Yes, we can. F9, it gives you the value of determinant. At the same time, if I want to calculate the inverse value of A, that is also possible. It gives me the value of the inverse of the A matrix, right? So now that is finished. Wonderful. We have learned a lot of commands. RAND, DET, transpose, INV, ones, zeros, I command, RAND, linspace, and colon command, numeral, size, and the bracket operation. So many things we have learned such a short time, right? That is one thing. And you also have basically some other few interesting things that you need to really learn, called as the reshape command and the remat command and the repeat matrix command. All right, so now basically let's say that I have matrix of A is equals to 1, 2 and 3, right? Okay, why not use the linspace command? Linspace command, between 1 and 3 I want 3 values. F9, I get the value of A. Now the thing is, I actually want to repeat this particular matrix 2 times along the rows and 3 times along the columns, or let's say I want 3 times along the rows and 4 times along the column, right? So what do? I want to repeat this matrix, right? So REP, repeat matrix. Repeat matrix. Which matrix do I want to repeat? matrix A I want to repeat. How many times along the row? I want 4 times along the row. How many times along the column? I want 3 times along the column. When I execute this, it's basically put this 3 times along the column. 1 2 3, 1 2 3 second time, 1 2 3 third time, 1 2 3 first time, second time, third time, and fourth time. So you have 3 repetitions along the column direction, and we have 4 repetitions, 1 2 3 4 along the row direction. The number of repetitions is inclusive of the first one, right? That is one thing, are repeating. So now what if let's say that I want to create let's say that I have a matrix of A, say random of 2 cross 4 and F9. This is the particular matrix that I need. I can reshape this particular matrix in a number of ways. What are the different ways in which I can reshape this particular matrix? I can make this matrix into a 4 cross 2. I can also make this particular matrix into 8 cross 1 or 1 cross 8. Okay, let me try and make it as 4 cross 2. I want to reshape this particular matrix. RESHAPE, reshape which matrix? A matrix. What is the size that I want to reshape it into? 4 comma 2, right? So basically this matrix has been reshaped into 4 cross. So but one thing that you need to take care is the indexing of the elements has not changed, right? What do we mean by indexing? Say for example, this is 1 comma 1, this is 2 comma 1, this is 1 comma 2, 2 comma 2, 1 comma 3, 3 comma 1, sorry 3 comma 3, 1 comma 4 and 2 comma 4. All right, so basically you see that every element has its unique location in terms of R and C, but there is another number that every element has, which denotes the location of that particular thing. This 0.01622 is in the first place, this is in the second place, 3 4 5 6 7 8. Okay, if you look at this, 1 2 3 4 5 6 7 8, right? The counting goes like for every column across the rows, and then switch the next column across the rows, and then go to the next column and once again across all the rows in that particular column. That's how the indexing has been done in MATLAB. So now basically if you consider 0.3923, it is in the element number 6 in this matrix. 1 2 3 4 5 and 6. If you look at the reshaped matrix, 1 2 3 4 5 and 6. See, the 6th position, the number or the value remains the same. This is the 6th position, this is the 6th position, both have the same value, right? So reshape matrix, it does not disrupt the element location in terms of the index number, but it does disrupt the rows and columns of the particular element, right? So now you can also reshape this matrix into 8 cross 1 matrix, 8 cross 1 matrix F9. You get this? Or in which case, if I write accidentally 7 and I get an error message, to reshape the number of elements must not change, right? Obviously, right? That is one thing. Okay, reshape matrix is finished. Repeat matrices. So you have learned basically a fundamental operations of arrays. Now let's work some with arrays. Hello.